Okay, so a rubber ball. A rubber ball is dropped straight down from a hotel window at a height of 176 feet. Every time it hits the ground, it bounces straight back up half the distance it just, I wrote dropped. Too many O's there. How far off the ground will the ball be after it has traveled up and down a total of 450 feet? So, what are they talking about? So, let me draw a picture. Again, it's all about a picture. So, here we have some tall hotel. And there's the ground down there. Okay, and the we're going to have this rubber ball, 400. Oh, actually, I'm going to change this number to make this problem more interesting. I'm going to go 242 feet. So up at a height of 242 feet out of a window, somebody drops the rubber ball. And so the rubber ball is going to go down and it's going to bounce up half the distance and then go down and bounce up half that distance and go down and bounce up half that distance and go down and bounce up half that distance, etc. It's just going to keep going down and bouncing up half as far each time, right? Half the distance it just dropped. Every time it bounces up half its distance. And it's we want to know the minute that it has traveled up and down 450 feet. The minute it has finished traveling up and down 450 feet, how high will it be off the ground? It's kind of like you're making a video of this ball bouncing up and down, and you, at the end, you want to figure out, you're going to freeze the frame the moment it has traveled up and down 450 feet. And right at that moment, how many feet is it above the ground? So, all right, let's just give it a try. So it's going to go down 242 feet, and it's going to bounce up half of that distance. Well, what's that? Well, I'm going to use my calculator. 242 divided by 2 is 121. So it's going to bounce up 121 feet. How far has it traveled at that point? Let me add those up. So it can be 363. So let's go further. So that was 363. So then it's going to go down another 121 feet, right? It bounced up 121, down another 121, so that'd be 484. Oh, that's too far. You see, I can't let it go all the way back down because it will have traveled 484 feet up and down at that point. You see what's going on there? Right? So that ball goes down 242, up half that, 121, down 121, but that's 484 feet. That's too far. We want to back up the camera, right? We're supposed to freeze the video the minute the ball has traveled 450 feet up and down. By the time it hits right there on the ground again, it's traveled 484 feet. That's too far. So let's back up. When the ball's right up here, 121 feet off the ground, let's back up to that point. Let me go back to that point. It was at 363 feet total travel, right? So how much does it need to drop to hit 450 feet total travel? We've got to subtract, don't we? If you subtract on your calculator, I'm getting 87 feet. So it's got to drop 87 feet. Those three numbers, those will add up. 242, 121, 87. Let me double check. Yeah. Yeah, so that's 450. So that's exactly when we freeze the video. When the ball has went down 242, up 121, and down 87, at that moment, add those three up, it has traveled 450 feet. freeze the camera. Freeze the video, I mean. Don't freeze the camera. Freeze the video. How far off the ground is the ball? That's what they're asking, right? How many feet off the ground? How high up? How high is the ball at that moment? How high off the ground? How high is the ball at that moment? How are we going to figure out how high the ball is at that moment? Everybody see what we need to do? 121 minus 87, right? Because it went up 121 feet, down 87. So whatever that difference is, that's how high above the ground it still is. So subtract that on your calculator. I think you'll get like 434. It's 34 feet off the ground. This must be 34 because 34 and 87 add up to be 121. That ball must be 34 feet off the ground at the instant it has traveled up and down 450 feet. We freeze the video the instant the ball has traveled up and down a total of 450 feet. At that moment, it's gone down 242, up 121, down 87. Those add up to 450 feet. Freeze the video. At that moment, it's 34 feet above the ground when the video freezes. So it's all about a very careful diagram showing the ball bouncing and keeping track of the up and down movement.